All right, get this music turned down. Hope you're doing well today. Here comes another rendition of Zephyr 101. Today we are going to be talking about Zcbor. And I'm going to switch over to the slides real quick. It's another great option if you are looking for some way to encode and decode data in an efficient way, in a similar way to JSON. So that's what we're going to talk about. Much better. Had to adjust my lighting a little bit. So this we're going to talk about. We're going to jump and talk about. We're going to talk about CDDL, which is essentially kind of like the language used to generate, if you want to, your own encoder and decoder using Zcbor, and you can also do it manually as well. So if you haven't already, feel free to subscribe, hit that bell icon so you get notified when these live sessions happen. And make sure I got audio. Sweet. And let's jump in. So this one came from Leo a while back. Sorry, Leo, it took me so long, but things have been busy here. So have you done a video on Zcbor? Well, I have now. So let's talk about it. Zcbor stands for Concise Binary Object Representation. If you think about it, it is a more compact way of generating JSON. They're kind of interchangeable. So if you go to Zcbor.me, so the website Zcbor.me, you can actually put JSON on the left side and it'll generate the binary Zcbor on the right side. And because it's similar to JSON, everybody loves JSON. It's easy to use or easy to work with, human readable. This is kind of the next step for embedded. So a lot of people, Nordic especially, I mean, they're the ones who basically built the Zcbor library for Zephyr. They're really going for it. They're really pushing it. So I've been a big fan of it for a while. I've been using QZbor for a long time. I actually have some Zcbor sprinkled around as well. So I don't have any preference. They're kind of different and good and bad in different ways. So it really depends on your application. It really depends on your preference yourself. So turning it on, all you got to do is do config wherever in your project.conf. You can do config Zcbor equals yes, and that will just allow you to pull in the headers and actually use this the Zcbor API. So I kind of mentioned this before, but QZbor it's all manual implementation. So if you wanted to create something based off a struct, you're going to have to go kind of entry by entry, make sure those entries are being encoded and decoded properly. You can do Zcbor manually, but you can use the CDDL. So for those who are familiar with protobuf is another kind of way to encode and decode data, very similar and I would say similar concept as the CDDL. CDDL I think is actually older, but you create the structures in a manifest file, and then you run it through the compiler and it creates the code for you. In this case, it turns it into Zcbor versus protobuf uses their proprietary way of packing everything in the most efficient way possible. You got protobuf version 2 or protobuf version 3. Who knows? There's a protobuf version 4. I don't know. But I have used protobuf in the past as well, and it has its uses. But this is what the CDDL looks like here. So we're basically saying, hey, I have this struct and I want all these entries in it. So I'm actually creating, in this particular instance, I'm creating a payload or a data point for a GPS fix. So I want to know the number of satellites, the latitude, longitude, altitude, some of these other parameters like HSTOP and SPKM. You have the timestamp or the TS there at the end. So we're saying, hey, this is what I expect the type for each of these entries to be, and then I use this to actually build out the encoder and decoder using CDDL. So what you can do, that's the part that's kind of missing here. It's like, okay, cool, I created this CDDL file. What do I do with it? And next step is actually, if you haven't already installed Zcbor, so pip3 installs the Zcbor, and I'll show you how to use it here. It gives you a bunch of options when you do run Zcbor. It gives you the option to only generate the decoder and only generate the encoder. If you put both, it'll do both. It'll actually, in one way, you can actually export it into a CMake file, which will then, or a make file, which will then generate the necessary C and H files. Or you can actually just generate those code and header files directly, which I've done here. What it will do is, if you look at these file names, they're just GPS_data. But what it'll do is it parses those names and then adds encoder or decoder at the end of it. So when it generates the decoder and encoder, they'll be in separate files rather than in one file. And what happens here is it goes through and then parses, and it creates the structure and also creates the encoder and decoder. So this is actually the CDDL generated struct for this particular instance. If you go back, actually, the one thing that's important is let me see if I can find it, the short names. So the short names entry, it's the last one on that command. If you don't put that in there, then the entries in the struct will be prefixed with the APS_GPS_data. So that's just something you got to keep in mind. That's their main thing. Is like, oh, you might get some collisions if you're using the same name. Well, you just got to be careful not to use the same name. Here is in the header file, this would be what the encoder looks like. So Zcbor encode app GPS data, and they placed it in, you see that GPS data encode.h. So, and it's taking a payload, so a buffer. You want to make sure you want to indicate the size of that buffer in the second argument, and you're going to pointer to the data that you are trying to encode, and then a pointer to a size value, which will basically indicate how many bytes were used in the buffer. So not always will the buffer be full. It might be less than the size of the buffer, and then you know how many bytes. When you read that payload length out, you'll know how many bytes you need to send. Yeah, here's the decode on the other side. So again, you're providing that raw data, so that you got the payload. You have the payload length. So this is actually the length of the payload, how many bytes are in the payload, and then you want to provide a pointer to that to the actual data. So in this case, you're just going to be using a zeroed out app GPS data, and then the size of the length out. Does that make sense? Do you need that size value? It's automatically generated, so, but there it is. Zooming in here, this is actually the code that's generated. Yes, it is not very human friendly. It kind of just chains everything together, so it's hard to read and understand. When I was looking at some old code that actually I used to generate using CDDL, and like, how did I write this? I don't even remember writing this, and it was auto-generated. I just kind of forgot. So if you do have to make changes, what I would do is make changes to your your CDDL definition, your little manifest there, and rerun Zcbor, and it'll regenerate the file and make any changes that is necessary. I would not recommend editing these manually because there's lots of room for error here. But you can see we're decoding all the particular values in this here, and then we're returning a return code. So again, encoding very similar state here, where we're going through each item and then encoding it properly. Again, auto-generated, something you probably don't want to play with too much. Let me see. What happened here? I got cut off. So if you want to use this code, so now you've generated the file. It's like, how do I use this in my Zephyr application? So similarly, what you have to do is make sure that your main CMake list.txt points to the directory that has that code in it, and then you can create a separate CMake list.txt, and then enter, target include directories, which will allow you to get the header file and reference it anywhere else in your code, in your application. And then target sources here, the second line is this should have like the decode.c there at the end. I don't know what happened, got deleted, but this is just saying, hey, I want to include that .c file in the compilation process. So those two things are important because then it'll allow you to access and use your newly created and generated decoder encoder. If you want the encoder, you have to create another line or another entry next to the decoder one and make sure that is available for Zephyr to use. One cool thing is that you can actually generate Zcbor. So this is taken from Nordic. So they get the credit, of course, but it's cool. So I was like, oh, I might as well just put this in there and try it. But all you have to do is you provide that the define in the command line when you want to regenerate your Zcbor, and it'll run the Zcbor command as if you ran it manually. So kind of handy, kind of cool. It's kind of built into the application, or you just run it manually, whatever you want. So pretty neat. Or you can actually just remove that conditional statement altogether and you can run it. You can generate every single time. You might not want to do that because it'll actually update the timestamp on the header every single time, and then I'm sure Git will be very angry with you. It'll be, hey, this file has changed. It's like, no, it hasn't changed. So we've generated the C files and the headers using Zcbor command line. You can do it automated and you can do it manually. Add them to CMake so Zephyr actually knows about them. And now it's kind of time to go forth and use the API. So here's a very, very simple and abbreviated example of that. So we've included the GPS data encode.h, and that also includes the struct definition is actually in a separate header file, but when you include the encode or decode headers, it also includes that one. So something important to know. Set up logging, so on and so forth. I've just created a very generic encode function. Has an enclosed buffer, encoded length. I've just put a bunch of bogus GPS data in here just for giggles. And we're going to encode that payload here. So I'm providing that buffer, that size of the buffer, which is 256. I like particularly, you might find yourself with having issues if you don't use the size of. So I always try to use size of, because if it's changed somewhere, they're at least they're in sync. Just something to keep in mind. A pointer to that GPS data, and then that size, we just want to know what the encoded size is at the end. So it should return positive or 0 for if things went well. If it's less than 0, we have an error. So we've generated the payload now, so you can actually use that buffer, and you have the size of how many bytes are in that buffer that are usable, that are part of the payload, and then you can use that to send out over the internet, over CoAP, over MQTT. I've done it all, and it's very handy. Comparing size, so if you have uncompressed JSON, uncompacted, it's 125 bytes for that payload. So this particular payload right here is 125 bytes. If you do it compacted, so you remove all the spaces and the return characters, and you'll get 87 bytes. Zcbor reduces it to 62. So you're saving 25 bytes per usage, and when you think about it, depending on how much you're sending over, maybe you're using Bluetooth or Wi-Fi or something, not that big of a deal. But when you're using, when you're using one of these guys, it's kind of a big deal if you can save as much data as possible. So using one of these guys, which is the send data over the over cellular, LTE, NB-IoT, you want to save those 25 bytes if you can, because it adds up over time. here's the result. So I mentioned Zcbor.me earlier. It's kind of a great little tool that you can pop stuff in there and see. I took that JSON. So this is the formatted JSON with the new lines, the spaces, everything. And I converted it to that 62 bytes. This is kind of like the diagnostic view here. So you can kind of see, okay, yes, I have a text field and then I have the value followed by it. That's all it really does is Zcbor will put the, you know, you have the label and then the value. They're just putting them together one by one all together there. So when you're going to decode, they're in the same order. So, but this kind of gives you a more diagnostic view of what the Zcbor payload is. You can also just generate it into just the pure binary or the hexadecimal. Really depends on what you're doing, but this is the default of what they have it there. Hi, Sam. Thanks for joining. You can also, so switching gears slightly, you can also, like I mentioned before, you can generate your own encoder using the Zcbor API. I find it a little, like, I like the fact that you can kind of auto-generate these things, and it's less of an issue. There's less mistakes, because I've definitely made them. You can take a look here. It's prone to mistakes, but it's not impossible, and I've done it plenty of times. One thing that I found that is very useful is if you use Zephyr's test infrastructure to test your encoder and decoder and make sure they are implemented properly. It's kind of a sanity check, especially if those things you're doing on your own. You know, you're not leveraging the auto generation of CDDL or anything like that. So I did do a video on testing. If you check out the channel, if you just search for test, I'll put a link into the description below as well. It's huge. It's great. It saved me a lot of time and headache, especially when manually generating APIs. Here is, this is another example struct. So I've kind of reduced the amount of complexity just because it's just a little bit easier to get it across to you guys. But we have an app motion data structure. We have a timestamp, and then we have the XYZ values of an accelerometer. So we're taking the accelerometer reading, and then we want to essentially encode that into a binary blob, which is a Zcbor, which can be, you know, consumed somewhere else on the back end or whatever, and decoded and used however necessary. So similarly to Zcbor, if you're familiar with Zcbor, you kind of want to set up your buffers and everything first and get everything aligned, and then you can actually start encoding the values into your blob, your binary blob here. So we want to create a map. We want to say how many entries it has. So it's going to have 4 entries. So that ES, 4. That 4 is just saying, hey, I have these many entries. And I think that Zcbor state _ E, that last entry is actually supposed to say how many entries are in that Zcbor blob. I believe you can also just leave it as 0. So, but you can experiment and make sure that the payload that you're generating is actually what you expect. So you can see why I was talking about how the labels and the values are just literally just put in next to each other. Like there's no special way of saying, hey, this value, or there's this label and this value go together. It's like they go together because they're put next to each other. So it's something to keep in mind. You can't just like put X, Y, Z, and then put the values after that, because it'll think, hey, Y is the value for X, which is not true. So put the label for X, and then we put that, because that center value is essentially a double, so or a float, we'll create that entry, and then we'll do it for Y and Z as well. Then we want to, if the timestamp, in this case I have made it conditional, so if the timestamp is there, we put it in there. If it's not, then we don't encode it. And that's something you can do. Like that's something that you might want to do a custom implementation, because you don't want to include the timestamp when it's not there. And that's something that the CDDL implementation can't really do. Is like, oh, it's like you can't really mark it optional, or maybe you can. I just haven't gotten there. But these are the type of things where like you can kind of tweak it and make it your own. then it'll save you some more bytes on the end, you know. So you can run the Zcbor map end. So we're ending the map, we're closing it. We're basically saying, hey, we're done with encoding, you know, setting up this map. And a map is just a key value storage means in Zcbor. And then what we want to do is just, it's been encoded already. So all you got to do is figure out the size. So compare where the payload is compared to where the beginning of the buffer, and then you get the size of it, and then that's it. It's already encoded, it's in there, you have the size, and you can use that to send your data over the wire or over the air, which is fantastic. So Zcbor, or Cbor in general, helps with your data usage. It's huge, it's great. I mean, JSON, it's there, it's still used. I still have customers using JSON because it's just easier for them to set up their web servers and just allow it to accept JSON, and they don't really want to think about it. But when you really want to get that extra savings in terms of data usage, check out Cbor or Protobuf or any of these other kind of packaging, message pack. All these things can be used in a Zephyr application on NRF 9160, NRF 161, NRF 61, 51, 31, all the NRF 91 series. You can use these to send data over the internet, over LTE or NB-IoT. Cbor CLI, CDDL, you can do that automatically, which is fantastic. And you can make changes to the definition, that YAML file, and keeps it consistent. Or if you really want to make it custom, you can roll your own API. It may take a little bit longer, but it might be worth it for you. So, and that is it for this one. If you haven't already, subscribe at the mailing list at jaredwolf.com, and I send out email reminders. Probably be sending more stuff out about the NRF 9161 feather, which is kind of in development. Actually, it's getting there, so it's gonna get to testing very soon. I just want to make sure it's compliant with CE directives and things like that. Doing EMI, ESD testing, or not ESD, but EMI, and I'm very excited about it. It's turning out to be a pretty awesome design. It's got a debugger built in, so you don't need an external debugger. A lot of customers were like, they're like, why do I need to buy this thing? It's like, this used to be like 10 years ago, this was like $15. It's $45 now, like almost $50 for this little cable. And they go bad if you use them enough. So I was like, okay, how can I make this easier for everyone? Build in the debugger. Why not? And then it works pretty well. I'm pretty happy with it. So very excited for that. Yeah, if you want more updates on that or updates on videos, I'll try to be making a little bit more videos as we go forward, now that I've kind of come out of my hole. And yeah, if you have suggestions, or if you want to see something, I will be doing a video on the new hardware definition setup in Zephyr, because those things, it has changed. They've moved to like version 2, which is a little bit different. So I'm going to be doing that for my own board, so I'm going to bring you guys along for the ride to explain how they've changed those things. So that will be coming in the future. But if you have any other ideas, you can email me, you can leave a comment down below, and I love to do a video for you if it's possible. So really appreciate you being here, and yeah, let me see if there's any questions. I don't think so. Just Sam. Oh, Livio, let's see. It'd be so cool to see the compliance testing procedure. I wouldn't be able to. So they're located in Taiwan. So I without me being there, I probably wouldn't be able to time it correctly. But I might be able to at least share kind of the test results and just show, hey, like, here's what we're looking for when we're testing. I want to make sure there's no spurious emissions. I want to make sure that it's not creating interference, that it's below the values that are necessary. Maybe I'll take a look at that report and I'll share it with you guys when it's done. I did similar process for the NRF 9160, so I will be doing that again for the NRF 9161. So that's a good idea. I will add that to my list. I'll do that right now. Add that to the list. Video on compliance. Cool. Awesome. Yeah. Yeah, I don't see any other comments. Thanks for everyone for being here. But yeah, we'll see you on the next rendition of Zephyr 101, probably next week, early next week. We'll see. But stay tuned. And again, if you have any comments, questions, leave them down below. All right. See ya. Thanks for being here. If I can just get this out of here.